Students, we are going to discuss new chapter Equilibrium, Unit 7, Lecture 1 on Equilibrium. Chemical equilibrium means the equilibrium which is achieved during the chemical equations. See, first of all, we are going to discuss the type of reactions. There are two types of reactions, irreversible reaction and reversible reaction. Those reactions which cannot be revert back is called as irreversible reaction. But those reactions which can be revert back means reactant to product and product to reactant is called as reversible reaction. And representation is also different. If it is irreversible reaction, there is only one arrow, and if there is a reversible reaction, there is the representation of double-headed arrows, forward direction as well as in backward direction. This is also the sign of reversible reaction, but this is the sign of equilibrium reversible reactions in which the equilibrium has been achieved. How the equilibrium is achieved and what are the conditions to achieve the chemical equilibrium we are going to discuss. See, here we have the reaction A plus B gives you C plus D. Now here A plus B is reactant and C plus D is product. In reversible reaction, A plus B gives you C plus D and C plus D gives you back A plus B. That means forward direction as well as in backward direction. That can also be explained with the help of graph when the rate of reaction of forward direction and backward direction becomes constant. Rate means consumption of reactant by the time is called as rate. If the rate of forward direction and backward direction becomes constant, that state is called as equilibrium state. That can also explain with the help of graph. See, students, here we are plotting a graph between concentration and time. Concentration of reactant and concentration of product. This is the concentration of reactant and it is a concentration of product. See, initially when the reaction has been started, the concentration of reactant is more and product concentration is 0. By the time the reactant concentration decreases and product concentration increases. A state when the concentrate change in concentration by the time becomes same. It becomes constant. There is no change in concentration by time. That state is called as equilibrium state. See, here it becomes constant and also here the rate, that is concentration by time, becomes constant. That state is called as equilibrium state. At equilibrium, the rate of forward direction is equal to rate of backward direction. That state is called as equilibrium state. Characteristics of chemical equilibrium. See, it is a dynamic process. As we have seen that reactant changes into product and product changes into reactant and keep on going one to another unless until they achieve a equilibrium state. So it is called as, it is a dynamic process. See, chemical equilibrium can be attained only if the system is closed. See, students, if any one of the product is gaseous and we are observing our process in open container. See, gas can be escaped out. So the reactant, the amount of product which are formed decreases. So the chemical equilibrium cannot be achieved because the gas is escaped out from the container. So chemical equilibrium can be attained only if the system is closed, reactant changes into product, product changes into reactant when their concentration are not decreased, not used by other system. Can be approached by any direction. See, initially reactant is changes into product. After that, product is changes into reactant. So, to attain the equilibrium, it may be do from any direction. It can be moved from any direction. They attain that position when the chemical equilibrium is achieved. Now the catalyst, as we all know, the catalyst increase or decrease the rate of reaction, but catalyst does not alter the equilibrium. वो help करता है reaction को forward और backward direction में जाने के लिए, पर reaction की equilibrium state को affect नहीं करता. Now the law of mass action. See, law of mass action states that, see, we have the equation A plus B gives you C plus D. It is a reactant part and it is our product part. According to law of mass action, the rate of reaction decrease or increase in concentration by time is directly proportional to प्रोडक्ट ऑफ कॉन्सेंट्रेशन ऑफ रिएक्टेंट्स. मतलब ए की अमाउंट कितनी है और बी की अमाउंट कितनी है उसकी कॉन्सेंट्रेशन के डायरेक्टली प्रोपोर्शनल होता है. किसी भी रिएक्शन का रेट उसकी प्रोडक्ट की कॉन्सेंट्रेशन पे डिपेंड नहीं करता, रिएक्टेंट की कॉन्सेंट्रेशन के प्रोडक्ट पर डिपेंड करता है. एंड व्हेन वी रिमूव दिस कांस्टेंट ऑफ प्रोपोर्शनलिटी वी आर यूजिंग के. सेम. So if the reaction is A plus B gives you C plus D, and where A, B, C and D are the coefficient of balanced equation. For example, N2 plus H2 gives you 2NH3. So if we have to write down the law of mass action, that means the reaction rate is directly proportional to product of concentration of reactant N2 and H2 raised to the power of their stoichiometric coefficient. जो इसकी मोलर कॉन्सेंट्रेशन है वो पावर में चले जाती है. एंड सेकेंडली व्हेन वी आर राइटिंग द कॉन्सेंट्रेशन, सी according to law of mass action, the rate of reaction is directly proportional to product of concentration of reactant raised to the power of their stoichiometric coefficient. When we are saying प्रोडक्ट ऑफ कॉन्सेंट्रेशन, तो प्रोडक्ट ऑफ कॉन्सेंट्रेशन टर्म को हम स्क्वायर ब्रैकेट से रिप्रेजेंट करते हैं. सो ऑलवेज कीप इन माइंड, डोंट पुट हेयर स्मॉल ब्रैकेट, हेयर यू हैव टू पुट अ लार्ज ब्रैकेट. Equilibrium constant. Say students, A plus B gives you C plus D. So rate of forward direction is directly proportional to product of concentration of reactant. Means A और B की concentration के प्रोडक्ट के डायरेक्टली प्रोपोर्शनल होगा. अगर हम बैकवर्ड डायरेक्शन की बात करें तो C और D जो हैं वो रिएक्टेंट होंगे और A और B प्रोडक्ट होंगे. तो रेट ऑफ बैकवर्ड डायरेक्शन इज डायरेक्टली प्रोपोर्शनल टू प्रोडक्ट ऑफ कॉन्सेंट्रेशन ऑफ रिएक्टेंट. उनके डायरेक्टली प्रोपोर्शनल होंगे. अगर हम ये कांस्टेंट यहाँ पर प्रोपोर्शनलिटी के साइन को हटा दें और कांस्टेंट ऑफ प्रोपोर्शनलिटी को प्लेस करें तो फॉरवर्ड डायरेक्शन के लिए के एफ यूज़ करेंगे, बैकवर्ड डायरेक्शन के लिए हम के बी यूज़ करेंगे. एज वी नो द रेट ऑफ फॉरवर्ड डायरेक्शन इज इक्वल टू रेट ऑफ बैकवर्ड डायरेक्शन. दैट मीन्स वी कैन राइट लाइक दिस. And when we are taking the ratio of Kf over Kb, then we obtained this type of derivation. See, so we can say that chemical equilibrium constant is equal to product of concentration of products divided by product of concentration of reactants. Let's take the example 4NH3 plus 5O2 gives you 4NO plus 6 water. So when we have to calculate the equilibrium constant. As we all know, equilibrium constant is equal to product of concentration of products NO और water, इनकी concentration raised to the power of their stoichiometric coefficients. इसका stoichiometric coefficient 4 है, इसका 6 है. ओके. Equilibrium constant is equal to product of concentration of product divided by product of concentration of reactants raised to the power of their stoichiometric coefficients. Means NO और water की concentration और ratio अमोनिया और वाटर की ऑक्सीजन की concentration और raised to the power of their stoichiometric coefficient होगा. I am again repeating, equilibrium constant is equal to product of concentration of reactants, product of concentration of products by product of concentration of reactant raised to the power of their stoichiometric coefficients. Thank you, students.